So just a minute, I'm sharing my screen. Okay, let's start the topic of list here. All right. Can you see my screen now? Is it visible to all of you?
Yes,
Is my
Manav.
just okay? Then no problem. We'll do one thing then. Yeah, let's continue then. We'll go with the next topic, that is. So we had a very detailed discussion about strings in the last class. I mean, yesterday's session. So what we do today is we will start with list, and let's have a detailed discussion about list. Just a minute. Yeah. Okay, friends. Let's continue about list class. Okay. Let's start with list. What is list, and why do we need list? Actually, if you look at any Python development, a list is also one of the very core data structure. You cannot expect a Python development without list. That much is important, list in Python. You got it right. Of course, even string, because most of the data what we get, it would be in the form of string, friends. Okay, and on that again we use list or dictionary or tuple, all these core data structures. Okay, now let's start with list. What is the list here? List is even another data structure or a collection. Okay, so that is one thing. So I'll write it clearly step by step so that you will be very clear. It is another data structure or collection. Okay, and one more important thing is this string, this list, tuple. All these are what we call is we call them as indexed data structures. These are linear data structures. So this is a linear data structure, simply speaking. Okay, next one. When we say linear data structure, all linear data structures have indexing. So what they have is these linear data structures, what they have, they have indexing. Okay, next one. Next after that is here there are very important things, very important characteristics here. So here list is dynamic. Dynamic means it is growable and shrinkable. You can add 100 or 1000 or 1 lakh or 1 crore or any number of objects into your list. You don't have a limitation. It will automatically grow, automatically shrink. Shrink means you can remove elements from the list. When you remove, it gets small. When you add, it gets big. That is called dynamic. And then here insertion order is preserved because it uses indexing. In whichever the order you add elements in the same order, we can print the elements or we can retrieve elements or extract elements. Insertion order is preserved here. Okay, next one. Duplicates, you can put duplicates into list. Okay, you can have duplicates. Okay, duplicates are allowed. You can add duplicate elements to a list or duplicate objects to a list. Anything is fine. And this is heterogeneous. List is heterogeneous. What is that? It is heterogeneous, means we can add different types of data, different data types into a list. So that is the meaning of heterogeneous. So we can put different data or data types into your list. Okay, that is one more important feature of list. Got it right? That is the quick idea, friends. So these are all important characteristics of a list here. Okay, I hope you are clear with this. Then after this, maybe while doing programming or some examples, you might get a better idea about all this, how it is dynamic, how insertion order is preserved, and you can see duplicates in the list. Okay, all that stuff. Now coming to the point, next one. Once we are we get a quick idea about list. Next thing we need to understand is how to declare a list. That is another important thing. Generally, all these data structures, this list or tuple or dictionary or set or frozen set, there are some more additional data structures. We might use them sometimes. Mostly we don't use them. I mean, frozen set, all this, what I'm saying. Okay. So all these different data structures, right? We can declare them in two ways. So how do you declare a list? We can create list in two ways. Okay. So I'll just write here. We can create a list in two ways. What are those two ways? The first one is using index operator, the square bracket. Second one is using list method. Of course, the second one can be used in different ways. Okay, this method list can be used in different ways, not just only for creating list. This can also used as it can also be used as a conversion function. We'll talk one by one. But these are the two ways which we use to create lists here. Okay, one by using this index operator, second one by using list method. Right, any of these two approaches should be fine for us. Right, now let's start with the first approach. Now the syntax look like this. To create any list, the simple syntax is just use some variable name equal to, simply you can just add elements here, some val1 comma, okay, val2 comma dot dot dot. Likewise, you can add how many ever you want to your list. So you can create empty list and later on add elements, or you can create elements and then you can create list with elements. You can do that in different ways. Depends on our necessity. We can construct a list in whichever the way we want. Okay, so this is another important thing. So what is that? This is how we created a simple list here. Simple example. We can take a simple example. What is that? Let's take something like fruits equal to, or fruits list, whatever it is, equal to something like, maybe I'll make it much more clear. Fruits list equal to, I'll put some fruits here, apple and then banana. Okay, and then you can add anyone, pineapple, anything should be fine. And then you can add some more if you want. Okay, orange, likewise. In this way, you can add whatever elements you want into a list. Suppose you just want a new number list, just then you can take some list one equal to, you can start some 1, 2, 3, 4, 5, something like this. Right? This is another example. Suppose you want a list with heterogeneous data, right? Something like 1, 2, 3, comma 5.6. Okay, comma something like you can add a string as well, some ABC, comma. Okay, some you can, if you want, you can add a boolean as well. By looking at this, you can easily understand this is heterogeneous. We are adding different types of data to the list. So when you do that, it is called heterogeneous, right? And another important thing is about next thing is, so once you declare a list like this is one approach. Okay. Second approach, you can use list method. I'll show you both the ways and how to test all different ways of creating list, everything. Okay. So if you want to create a list by using list method, so what you can do, something like you can simply say some list one equal to list. And this creates just an empty list. So what this creates is, this creates an empty list. To that again, you should keep adding elements. Of course, you can also use this to convert any other data structure to list here. So this can be used as a conversion function, or this can be used to initialize a list here or to create a new list. So we'll work on both. Later on, you decide which one to use. It's up to you. Got it, right? So next one. So this is simple idea. Maybe if you want to, once we create empty list, how to add elements to the list means there are different ways, right? We can use indexes to add element one by one, or else we can use methods, built-in methods to add elements to a list. Different ways are there. Okay, so that is the idea, friends. Now, after that, so what is the next thing? So this is about declaration and initialization of a list. Next, understanding indexing of list. Same like string. So we had discussed string in detail, right? And understanding list. And what is the discussion we had here yesterday about string? String has indexing. It has both negative and positive indexing, all that. By now you should be very clear on that discussion. Same thing applicable for list. This is more like a revision for you or a recap. So understanding indexing of list. Maybe I'm writing here indexing of a list. So what is that? Suppose you create a list, some L1 equal to, you have some 5 elements here. So here this has both positive and negative indexing. So positive indexing is 0 and then 1 and then 2 and then 3 and then 4. And negative indexing is again if the size is 5, it starts with -5 and then -4 and then -2 and then sorry -3 and then -2 and -1. So this would be the indexing. This is negative indexing. Okay, any indexing is fine. We don't have any issues with any kind of indexing. We both are there in Python. We have positive and negative. Which one to use? It's up to you. Most of the time we generally use positive indexing, but still, if you wish to use negative indexing, still you can use it. It's up to you. Right? Next one, and you can use mixed indexing as well. It's up to you, friends. So this is how indexing is created for a list in Python. Got it, right? Or indexing is assigned in Python by the Python interpreter. This I think you should have some idea about this scenario. Now, as you know, on all this, one important thing is on all indexed data structures, we can apply slicing. One of the very useful thing is indexed data structures. We can apply slicing. Again, if you want to break that list or string or tuple or any of these indexed data structures, then applying slicing is one of the best choice for us. Of course, we can do it in different ways, but slicing is the best choice if you want to extract part of a list or part of a string or part of a tuple. Right? We apply slicing. That is the idea, friends. Next one. So finally, this is how the indexing is created for a list in Python. I hope you should be clear. Now, next one. So how to, we can start checking one by one, testing one by one here. Okay, let's use PyCharm. Let's start creating few programs, and later on we can see different methods of list class. And one more important point is a list is a built-in class again. This is also a built-in class. All these are objects in Python. Even list is an object because they belongs to class. I hope this is clear. Okay, what do we do right now? Let's go to the PyCharm. Let's start understanding the topic of list. So what I do is, so this is something which I am building for, I'm working on this actually. I'll maybe later on, if possible, I'll bring in that scenario for you also. Now, right click and then what is that I should do? New, and then create a new Python package for list exclusively. I'm creating a new package again to keep all my list programs in that package. Okay. Seems like it is a bit slow. Not sure why. right click and then new and then see now Python package. And then just give it as list enough. So we created list now. Should have created by now. So yeah, it is created now. Where is it? Where is our package? Somewhere it sits somewhere, okay. Array. Okay, you can see here now. See here. So this is the Python package we created. And if you, to be very clear, if you want to observe, if you want to understand what is a package, package is something where we keep all our Python programs. It's collection of modules. And if you create any module, any package in Python, by default, that package should have this init.py. Just remember this. By default, nothing will be there in this. You don't have anything in this. It is an empty .py file, but still when you create a Python package, this init file should be present in that package. Got it right, friends? It is a standard process. Even if you don't keep, nothing happens, but it is a standard process. Right. Next one, create a new file. You can just say it as a list underscore demo, enter. Okay. So now I start the very basic things of list here. Okay, so what is that? How to create a list? Some L1 equal to. I'm just creating a simple list here with 5 integers. Now I want to print it. So this is first thing. What is that? Creating a list or declaring a list. Right, with how many integers? 5 integers. Next one, you know the indexing, right? Already I had just quickly discussed about how would be the indexing, the positive indexing and negative indexing both. Now, second thing, printing or getting elements from a list. So what I'm doing now, again, I'm just showing you quickly how to get elements from a list. These are very fundamental operations. Like whomever very new to Python, this is the very basic. And anyone, if you should learn Python, this is the starting point. Okay, getting elements from Python. But what we do is we just start from the very fundamentals. Slowly we will take it to the next level, advanced level of coding. That's how we plan our sessions. Okay. So how do you get elements from Python? By using index, because we know all these are linear data structures. The only way we can extract elements from these data structures is one approach is using index method. Okay, so how do you do now? Print off. If you want, you can directly print values L1 of that variable name of 0. This will return element from 0th index. Right? What this does? This returns or get element from what it gets element from not elements, element from 0th index. Okay. So that's it. Got it right, friends? So next one. Similarly, you can print other elements as well. How do you print it again? Suppose if you want to extract, if you want to get other elements, simply add one more print. If you want next element L1 of 1, it gets element from first index. Next after that is a second index, and then third index, and finally fourth index. This is how you try to what you can do. Get elements from a list here. You know, right? The index of list here ends with 4, starts with 0, ends with 4. Don't try to extract element from 5th index. It leads to index error. If you try to access an index which is not there in a list or in a linear data structure, it leads to index error. Okay, just keep in mind, friends. So this is the idea. This is the very basic program. We just declared a simple list and then trying to extract or trying to get each element from the list by using indexing here. If you want, you can use my negative indexing also. Suppose I want to get last element, I can say L1 of -1. Last but one element, I can also say -2, like this as well. Okay, both are like, there is no difference here. Printing third index and fourth index is as same as printing -1 and -2, using -1 index and -2 indexes. Okay, let's quickly run this, test this code here. So you can see here, all elements are printed here, 1, 2, 3, 4, 5. Got it right? So we can use both indexes, a positive index and a negative index, to get elements from the list here. I hope this is clear, right? But this is only just for quick discussion here. So as we are just starting the concept of list, but this is not what we exactly want in programming. Okay, I'll get back to that stage quickly after discussing few more important things about lists. Okay, this is starting point of list here. Another one, next one. Right, one more important point I just missed to introduce while discussing about characteristics of list. What is that? Very important. This is very important. You can also see it in any documentation. The very important is list is mutable. What is it, friends? List is a mutable data structure. Okay, I'll just put DS. Okay. What do you mean by mutable? We can modify the elements of a list. Like string, like other core data types, list is not immutable. List is mutable. Okay, they are all immutable, but not list. List is immutable data type or data structure. Okay, see, to test that, suppose you see here. Now I want to modify element of 0th index. Now what I do, I'll just try to set element to 0th. I want to replace this element of 0th index. So what I am doing is testing mutability here. What I am testing mutability. Mutability means we can modify. So the meaning of that is we can modify a list. Okay, just showing you that properties, characteristics here. First thing you can see, you can add how many other elements you want. I'll show all that step by step. Now here, I'm using L1 of some 0. So this is how we can reassign or reset a value to a string. You can see like this by using this index. I'm just adding 100 here. When I say L1 of 0 equal to 100, what happens is the element in the 0th index is replaced with 100 here. Suppose some element will exist in 0th index, right? In place of that, what happens? 100 is assigned. So if it is modifying, if 100 is updating existing value of a list, then this is mutable. If you are able to replace old value with new value, definitely list is a mutable data type. Right? What we do right now, we do one thing. Let's print the whole list in one shot. And let us observe the change that is applied to the list here. Okay, let's run it now. Now you can see here, if you look at the output, in place of 0, earlier it is, what is it? 1 here. Maybe you do one thing. Before change, you do one more print. So here I am adding a print and printing the whole list before we make any changes. Okay, let's test it now. Now you can see this is our old list. After updating that 0th index with 100, you can see that list got modified. Now in place of 0, in 0th index, you can see 100 instead of 1 here. That itself shows that this list is mutable data structure or data type. You can say data type as well, no problem. Got it? List is mutable. You can modify elements of a list without any issues. And this is how you can do. If you want to replace any value in a list, you can use that index and reassign that value to that index. So very simple process. Got it right, friends? So this is about mutability. Next one, dynamic nature. Dynamic means you can keep on adding elements and you can keep on removing. That I'll discuss with methods. Okay. Anyhow, that is fine. Next one, insertion order. You can see here in whichever the order you add elements, in the same order you can see the output in the elements. That is called preserving insertion order. Got it right, friends? So that is one more important thing. Next one. What else we have here? We had discussed duplicates. You can see if you want, you can also put some 1, 2, 3 as well. See, I'm adding some duplicates to the list. We don't have any problem. List happily allows duplicates. What list does? It will happily allows duplicates. Maybe now if you try to print it, you can also see duplicates here. You can see here. Means what? A list allows duplicate elements. Just observe all this. Later on, we'll talk more about how to filter duplicates, all that scenarios. But one important thing to observe here is list allows duplicate elements. You got it right, friends? This is the idea. So this is a quick introduction, how to create list and how to add elements. And then this is one approach of creating list. I'll show you another approach as well. And how to extract each element from a list here. This is what it is doing. And then how to do update on a list. We are doing an update operation, means we are modifying, modifying existing value of a list. That is called update. Right, all this, we did all this here now. So that is the quick idea. Next one. So what is next thing? Say approach to, I just want to show you how to create how to create a list in using list method. Another way of creating list using list method. So this is creating a list. How? Using list method. Of course, this list can be used in two ways. I told you clearly. One, for creating empty list. Two, it is also used as a conversion function, like how we used other conversion functions like str, int method, float method, all that. Even list can be used like that. I'll show once we move a little further on the topic. I'll show you how we can apply conversion of this data structure to a list. Right, now let's just create a L2 equal to list list. Now you print L2 directly. You don't need to do anything, just to see how this list look like. Okay, we didn't add any elements. So print it and see. Now you can see an empty list created here. You can see here. We don't have any elements, that is fine. Maybe you might ask questions like how should we add elements to the list? Right, that I'll discuss very clearly. But I'm just showing you before we go a little deeper into this list topic. I'm just giving you a clear fundamental this thing. Got it right? This is the second way of creating a list. This helps us to create empty list, and later on we can add elements one by one or as a group of elements, or like you can copy a whole bunch of from some other source. It's up to us. There are different ways where we play with lists when you are doing in development. Okay, so this is the idea, friends. Next one after this. I think all of you are good with this, right? Fundamental should be fine. Next one. So this is okay, but now when you are working in a big project, getting each element from index is not a standard process. This is not a recommended one. Because if you try to get element by element, right, there are 1 lakh or 1 crore elements, then the day will be just, 1 day or 2 days, it won't be enough to do that. So what is the best approach here? Using looping, always using looping on these kind of data structures is a standard practice. So we are moving to that step now. What is that? Iterating a list. So the next topic is I'll just create few quick programs, small quick programs. So list underscore iterate demo. You got it right? Enter. I'm closing this one here. Okay, no need of this. Already clear with this basic, right? How to create list both ways using index operator and using list method, and then how to get each element from a list, and then also how to update some element on a list. All this is clear, right? Next one. I'm closing this. Now you take a list, anything of your choice, like, just some 1, 2, 3, 4, 5. Maybe if you want, you can add duplicates as well. It's up to you. Right. Next one. I don't want to get each element by element here. Right. So we have seen just few seconds back how to get each element from a list. That is fine using that index. But I don't want that. What I want is I want to iterate a list directly. That is what generally we need when you are working, when we are playing with lists or when we are using lists. Okay, so next one, we are creating a list, and next thing is maybe you can say integer list or something. Next, iterating a list. Always applying iterator is the standard practice. Right? How do you apply iterator? Simple, right? We know for some I in, right? For in is the loop we can apply. For I is a dummy variable. Most of you know this because we have used this for number of times so far. And you see, after the basic discussion, most of the time we are using for loop. You don't see we are using much of while. Even this happens when you really work in any project. Okay, for I in L1 colon. Okay, you don't need to do anything. You don't need to use any index to extract element from list if you are using this special for loop. Okay, we just need to use dummy variable here, and then you have to pass that list variable here. That's all. This is a place where always we pass a collection. And you know the execution flow, right? I have already many times I have did a debugging. Even now I'll do that quickly. So what happens each time this loop iterates, one element from the list starting from 0th index, one element from list is copied to the dummy variable I. And from this dummy variable, we get that and do whatever we want to do in that for block. Which block? For block. Okay. So right now I am not doing anything. I'm just printing I. That's my basic thing as of now. So I'm just printing that I here, friends. Okay. What I do right now, just run this code now. Just run it. You can see all these elements are iterated element by element. All these values are iterated element by element here. You can see here. And order is same as you are passing here. No, there is any change here. We don't have any change here. See this. This is what insertion order is preserved means, because these list uses indexing. So we don't see any change in the order of elements here when we extract them, when we print them, when we read them. Okay. And when we do any other operations. Okay. That is the simple idea, friends. Got it, right? Next, after this, suppose let's just put a debugger here and see the execution flow of a list. Okay. And once you put a breakpoint here, right click on this program and then say debug list iterate demo. And then it starts. Okay. Applying this debugging now. It is at the very basic thing. See here, list is already created, loaded into memory. You can see here. Right, all that variables, whatever that is created in memory, right, are loaded in memory. You can see at this bottom window when you are debugging. Okay, so a list is created, and you can also very clearly see here one important thing is the indexing. You can see the indexing here. In 0 you have 1, in 1 you have 2, in 2 you have 3, in 3 you have 4, in 4 5, something like this, friends. And here you can even see the length of that list here. Length of list is 8 here. You got it, right? There are some protected attributes. It's not showing anything there. Special variables. These are all magic variables. And you can also see that main here, right? If you want to explicitly define main, you have to mention this, that name equal to something, and create a driver program. Whatever the code you put in the under that main, we technically call that as a driver code, because from there the actual calling starts. You got it right, friends? So all these are all very magic variables here, right? That is the quick idea. Next one, let's get into this discussion now. So what is that I want to do? I just want to iterate a list. Come here, you can see these are the options. By default, if you want to go step by step, right, then apply step over. Okay. If you want to go by line, then you can or iteration by iteration, you can apply step over here. Right. This is used generally when you are trying to debug a method. If you want to get into a method and see line by line execution of a method, you should use this. Okay. These two are very much needed for us. Other two you can ignore for a while. So step over, you can see it started. It started now. It copied one from list here, the first element. You can see the value changing here. And when I say again, it prints it, come back again, copies next element into the I, and then again it prints it. And this happens till how till when this happens till all elements are iterated from the list. Okay, element by element, not all at once. Only one element is iterated in each iteration. Okay, you can see the execution flow. So 5 is copied, next 6 will be, we don't have 6 again, one is copied, 2 is copied, 3 is copied. Finally what? The whole list is iterated. It will jump from it will again come out from there once the iteration of whole collection is completed. If I is 3 means by now we have completed iterating the whole list. Now when I say step over again, you can see it just comes out of the this loop here. You can see here, and you can also see the output in the console at the same time. Right, this is the quick idea, friends, how this for loop iterates over this list collection. Now after this, what else should we see now here? With this knowledge, you can do couple of logics. You can work on couple of logics. Okay, you can add few more elements here, something like 8 and some 7 and some 9, something like this. Okay, we can quickly check on few things. What is that? So before I go and talk about methods of list class, that is very important thing. After that, we will work on some use cases. Okay, some POC projects, some small projects on list, which helps you, which develops your understanding towards list and how to implement logic on list, all that. Okay, this is fine. We are done with iterating a list. Next thing is we need to do few programs on list before I go and talk about what is that. Go and talk about list class methods. Understanding API is very important again. Okay, anyhow, no problem. So now what I do is I'll do quickly some 2 or 3 programs on list just to give you a quick idea about to make you familiar with list. Okay. Next, what program shall we do on list now? See, right click new, simple program, checking if elements of a list are even or odd. Right. So now just one even list and creating even list. Otherwise, I'll do one thing. Even before I do this, let's jump to the list methods. I just want to get into this topic now because that makes you more comfortable to handle these programs. So list has so many methods, friends. Let me introduce all methods quickly. Later on, we jump to the programming part, application part, otherwise applying part. So as this is a built-in class, it has many useful methods, which is very much they becomes very handy for us. They are very useful for us. Okay, what are those methods? First thing, append method. I'll go one by one. Okay, right. The easiest way is so if you are very new to the programming and you don't know anything about list, maybe I'm creating here one more program and again writing here list underscore methods here. Okay, so just create a simple list here and add some elements if you want, or you can create empty list also. It's up to you. Right? Empty list or a list with some elements, anything is fine. So now when I say list one dot, now you can see there are all these methods here. I'll go one by one in the order which we use, we play with list. Okay, the first thing is here append method. So what is this append for? If you want to add any element to a list, right? If we want to add any append means add element to a list. Want to add any element to a list. Elements in sense anything. It can be int or float or double or string, whichever you want. Okay. So, but one element, not more elements, not multiple elements. Append helps us to add one element at a time to a list. So then we use this. Otherwise, we can simply instead of all this, okay, what append to add an element to a list. That's all. So that's all, friends. Okay. So simple syntax is very simple. That list dot, you have to use that dot operator when you are calling methods of any class, right? If I should apply append, let's start with append now. So we have an empty list. Now I want to add some elements to the list. By now you understood we can use append method to add elements to a list. Then what do? I can say list dot append of some 10. Again, you can add how many other elements you want, friends. Let me just add those one by one. So now we have added 10, and after that list one dot append of 20, and then 30. You can also use loop to add elements. It's not like you should add like this. Okay, we can use iterators to add dynamically elements to a list. Now you can see I just created an empty list and I started adding elements. Even I didn't mention any size. I didn't specify any size here. So that's what dynamic means. When you keep adding elements, the size of list keep on growing. If you remove elements, the size of list keep on shrinking. It shrinks, means it reduces. Right? That's what we call dynamic. One more characteristics of list here. Right? If you want, you can add few more elements to a list here. Something like I'm just adding some 4 or 5 elements, some 40, some 50. The same thing you can simplify it. The same approach you can simplify with the iterator. I'll show you that also one by one. Now you can print this. What you can do is print some list of one. When you do this, just see how these elements are added to the list. You can see all these 5 elements are added to the list here. You can see. Generally, append acts as like insert last. As per if you have some idea about data structures in C or C++, there is a method which we apply on linked lists. If you remember, if you have some idea, if you don't have idea, ignore all that. So what is the nature of append is append performs a insert last. It always add elements as a last element. Okay. It does insert last. Maybe having this knowledge helps you somewhere. Okay. To understand the performance of your application. Right. It always inserts elements at the end. So, but anyhow, now when you keep adding it, add element by element to the list here. Now this is the output of list here. You can see here. Got it, right? This is one method, append. You can dynamically add elements by applying iterator also. So something like, using iterators. Using iterator also, you can dynamically add elements to the list. How? Like you can see here now. So for I use range function. Range of some, I want to add some, okay, 20 to 30 elements, 20 to 30. Okay. Or we have added till 50, right? I will add some 100 to some 105. So what I put here 100 comma 106. Okay. Now I am trying to append these elements which I am iterating through for to the list here. How do? I am iterating from 100 to 106 using for here. And just you can simply say list one dot append of I. Just pass that I to that append method. Iterate the list, get that value into I, and pass that I to the append. This simply adds how many elements you want to the list. Right, I'll just show you how beautiful this scenario will be. Let me run this first and show you first the big bunch of list. I ran it, but you are not seeing the values here. Don't worry. I didn't print updated list. I am printing list here before this iterator. If you want to see all values from the list, you have to print it after iterator. Then you can see even this values added to the list through iterator. Now right click and run this. You can see here how many elements are added here. You can see apart from 50, remaining 4 or 5 elements are added here. Remaining 6 elements I think are added from 100 to 105. Right? Suppose you see here you start with 1. Okay. How many elements you want? You add some 10,000. Okay. This is 10,000, right? Now you see here. Run this. Now you see just in a single shot it generated how many elements here? It almost generated, you can go and see, it would generate, see that it's going on to the towards left, okay, towards right, sorry. And you can almost see 10,000 elements there. See, almost you are seeing in just in a single shot, it just generated how many elements, friends? 10,000 elements. Similarly, if you put one more 0, it becomes 1 lakh. It just run it. You can see list gets updated with how many elements? See, 1 lakh elements here. See, just in a slice of a second. Got it right? Just in a fraction of seconds, it generates these many values. Suppose, of course, as the range keeps increasing, it might take a few seconds time. Right now, I put 10,000. See, this is dynamic nature of list. Now we have 10,000 elements in the list. Okay, maybe it just reduced 1. That's fine. Maybe because this is excluded and element is excluded. Right. If you want, you can add just 1 to that. You get up to 10,000. Sorry, 10 lakhs. I'm saying 10,000. Sorry, friends. 10 lakhs. I'm correcting my typo. Till 10 lakhs. So this itself shows, right? You just created a simple list here. And to that you are adding, right, hundreds, thousands, lakhs of elements. Even if you want, you can add one more, it becomes a crore, 1 crore. And even it can add that list can hold that 1 crore elements. Got it right, friends? I'm just, stopping that discussion here about dynamism of list here. This in the same way how you are adding objects, in the same way you can remove objects. We added integer objects now, we can remove them also. That is fine. Just a quick idea to all of you. Understood, friends? So that is the idea, friends. Maybe you can put 1 to 10 now. Just leave it like that. Okay, you can see these are the elements what we have in the list. And this is how append works. And this is how list works internally. It is a dynamic data structure. It keeps on increasing how many other elements you add to that list. There is no limit for that size of that list in Python. Right? That is what collection is all about. Got it right, friends? Next one after that. So we are done with which method? Append method. Next after that. So append add elements always at the end. There is one more method, insert. What is insert now? Insert is used to insert element at a given index. List has index, right? So now here this is the list. Now I want to insert element at 5th index. Which index? 0, 5th index. I don't want to count. I want to insert element at 5th index. 5th means 0, 1, 2, 3, 4 here. Whichever value 1 is sitting, that position is 5th index. You got it right. Means the 6th position. Index is 5, position is 6. Now I want to insert an element into the 5th index. Then simply what I can do, I can use insert method. What is insert? Insert is something which inserts, what it does, insert element at a given index. So the difference is, for append you don't need to provide any index, because by default append adds elements at the end of the list. Add an element to a list as, otherwise I'll just write like this to be more clear at the end of the list. But whereas insert adds element, inserts element at a given index. For example, you see here now, this is the program. Now after this, okay, now we are testing insert method. These are all very important, friend, and useful for you also. You need to use in your coding, in your programming. Okay. So simply you can say list one dot insert of, not index, insert. Index also we apply. I'll show all that one by one. Now I want to add which element. So I want to add anything. I put 100. Okay. So where I should add in the fifth index. Okay. So you can see when I just added 5, 5 is taken as index and object is 100. Now this 100 is placed into fifth index. Now the question is, already there is an element in fifth index. What happened to that element? Will it get replaced or will it get shifted? There is a quick question. What happens to the element in fifth index now? Will it get replaced or will it get shifted? So that is the question. So shifted or replaced, what happens? If you want, you can answer in the chat box. Right here, there is no concept of replace. So elements get shifted to next position. That's all. If you insert something in the middle of list using insert method, then the element that is already there will get shifted to next location or next index. That's all. You got it right, friends. So there is no replacement or anything, right? We don't miss any value here. Just print it now again. Here you have to put print after update, after using insert, so that you can see that change or that insertion of value into the list. So put one more print here and then print that list, run it now. Now you can see 100 is inserted into fifth index. As we have counted earlier, one is sitting in that index. Now we updated that we inserted 100 into that index. So one got moved to the next index. You can see here. There will be just a simple shift here. That's all. Of course, this is a costly operation. By to insert 100 here, we have to shift all these elements by one index. This is a costly operation. Adding elements at the end is the best operation. Keep in mind, friends. Appending is a very efficient approach than this inserting in the middle operation. But these are the two different ways of adding values to a list. But which gives you best performance? Is it append or is it insert? Can you please answer in the chat box if you wish to? Right? Which gives best performance? Because I gave a very clear difference between list and this append and insert here. Understanding these differences is important. Which gives best performance is important. You need to understand all that, friends. Got it right? So that is the idea. Got it? So that is the idea of what this in append and this, what is that? The other one is the insert. Before we close our session today, I'll give you one beautiful scenario, simple and interesting scenario with list using append. Now let us get into the little programming now, because you have some background and you know some methods from list class which helps to understand what I am doing. So let us create a small program. Let us do one thing. Take a list and split it into even list and odd list. Take a list of integers with both even and odd integers and split that list into even list and odd list. So even and odd list. Okay, we should do this program now. Now simply take a list. So from 1 to 10, that should be fine for us. Okay. Now let's apply a simple program. So when you know how to just do these basic programs, then you can play with very bigger programs. See here. And you have so many scenarios. If you really want to work, I have gathered very medium to complex scenarios. You can apply that as well. So now what is that I should do? I should create two lists. What is that? Even underscore list. Just create an empty list. Just create empty list. Don't do anything. This is what you should do when you are working in any kind of problem solving. Sorry, even it may be your development as well. Because I do development, right? Automations generally. I create a lot of empty lists like this first, because I need to filter my data to some like not even list or odd lists, but I have to filter data. So creating this empty list and later on adding data to that list is a quite common practice. Right. Next one, odd list. Another one. This is very simple. This is not really a challenging issue, challenging concept or program, but just giving you a quick idea. Right? Very interesting though. Right. So what did I do now? I declared a list. Okay, integer list otherwise with first 10 integers. Next one, what I am doing now, declare what this empty list here, even list and odd list. Now simply what you have to do, very simple job. Iterate list. What is that? For I in L1 colon. You should do a simple condition check. Already we know how to check if an element is even or odd. Even or odd. That is very clear for us. So what do you do if I percentile 2 equal to 0? If it is even, then you should add that I to which list? Even list. If this condition is true, add I to even list. Otherwise, add I to odd list. To add an element to this list dynamically, what is that I do? I use append method here. Which method? I don't use insert, but what I do? Append is the best choice here in this kind of scenarios. Okay, more than insert everything. Insert is something used when if you want to insert an element at a given index and you don't know the index, you want to blindly filter data, using append is the best choice. Okay, so now what I do, I just say L1 dot, not L1, sorry friends, I want to add even list dot append. If that I is even, add that I to even list. You can see just append it even list. Else colon, what I can do, I can simply say odd list dot append of I. After this, what I can do, this is done over. See here, a very simple this thing here, simple filtering. Just iterating list, applying a condition. If condition is satisfied, then you have to add that element to the even list by using append method here. If condition fails, if it is odd number, just add that I to odd list. Done. We are done with this filtering data. Very simple scenario, right? So we are iterating data here. And after that, what is that we are doing here after iterating? We are filtering and then what? We are segregating data according to that type of that data. If it is even, we are keeping that data in even list. If it is odd, we are moving that data to odd list. Right? In this way, we are trying to filter data according to the nature of that value. Okay, finally print them. Simply print them. You can just print here the even list is. Okay, you can apply this now, this placeholder, and then you can apply format and then just pass that. Okay, what is that you can do? Pass even list array. Okay, next after that, copy paste this and same thing, just print it. Odd list is. Okay, simply print it. Simply you can say odd list. Okay, and then save it and then run this now. Now you can see two lists now separated. You can see 2, 4, 6, 8, 10 in one list. 1, 3, 5, 5, 7, 9. Maybe there is a duplicate. Yeah, you can see here. If you have duplicate, it try to add that to the odd list itself. No problem. Let it be. So this is simple idea, very basic program. But you can see this is very interesting though. What is that? To start with this list programming and how to dynamically do this validation and dynamically append data to some list here or filter data to lists. So this is a very good start for us. Okay, I'm just sharing this program. If you want, you can give a try on this as well, friends. Okay, so this is the idea, friends. Got it? So what we do is tomorrow I'll talk about my many functions. There are remove functions, some 3 or 4 types of remove functions. We'll talk about all them and clear differences like how we had for append and insert. Similarly, we'll have a clear differences between all things and make sure we understand everything properly. And we don't stop there. If you just understand methods and stop there and do some very simple programs, it is not going to help. What is that you should do? You have to again apply that with some scenarios. That helps you to think better, okay, and apply better. We'll see all that step by step. Got it right? So that's all, friends. If you have any questions, you can ask me. Otherwise, we'll give it a call for today. Any more questions? No questions?